Hello. We'll draw isometric view of this object using Autocad. Read the problem. Orthographic projections of an object are given below. Draw the isometric view. Okay. Orthographic views are two-dimensional views. Which two dimensions appear in the front view? Length and height. Which two dimensions appear in the top view? Length horizontally and width vertically. So orthographic views are two-dimensional views, but isometric view is three-dimensional. And in isometric view, we measure these three dimensions in these three orientations. So vertical axis is of course height axis, but the other two axes, that is length axis and width axis, are at an angle 30 degrees. So out of these two axes, which axis is length axis and which axis is width axis? How to take that decision? Try to understand. And exactly to help you to take that decision, this point O will be given in orthographic views. So listen, right end of the object and left end of the object appear in the front view and also in the top view. This is right end of the object, this is left end of the object. You must be knowing that in the side view, right side and left side are inseparable. And that is why don't refer side view, refer front view and top view and check whether point O is on the right end of the object or left end of the object. If point O is on the left end of the object, then it means that left side axis is to be considered as width axis. So this axis is width axis, and how you have taken that decision? Check on which side point O is. Now one very important thing you should know, that if point O is missing in orthographic views, then this is very important. If point O is not given, how you are going to take that decision? Check which side of the object, right side and left side. It is comparison between right side and left side. Check narrow side and wider side of the object. And then take the decision, narrow side is a point O side. So in this case, point O is on the left side or narrow side is left side. So left side axis is width axis. Now let's check what are the dimensions. Length 90, but extreme left edge is curved edge. So we'll have to add its radius because 90 millimeter distance is up to center of that curve. So 90 plus 35, length is 120, height is 40, front view vertical dimension is height. And in the top view, vertical dimension is width. So what is overall width of the object? It is diameter of this semicircular edge, and that is 35. So length 125, width 70 and height 40. These are the three dimensions. So add a larger two dimensions, 125 and 70. So that is approximately 200. So 200 by 200, that much space is required on drawing paper to complete this drawing. This rough estimate, how much space is required on drawing paper. Okay, now let's open our Autocad software. Open new drawing. Let's set the limit. Limit, enter, 0, 0, enter, and 200, 200, enter. Now zoom all, zoom, enter, all, enter, and this is how you got that required space. Now check whether these toggle keys are on. Whether grid you want or not, that's your choice. This toggle key must be on, ortho mode must be on, snapping lines must be on, snap cursor reference points must be on. Check all these keys are on in this menu, and now we are going to draw isometric views. So isometric drafting must be on. So now try to understand here. In isoplane left, you will able to measure in this problem width and height. In isoplane top, you will able to measure length and width. And in isoplane right, you will able to measure length and height, or you can draw lines parallel to length and height. Check drafting and annotations here. This window I have created just to make you understand which button I press or which key I use to give commands. Now let's complete the drawing part by part. check the drawing. Clearly you can see that there is a semicircular plate of height 20 millimeter or thickness 20 millimeter. This is that semicircular plate, and here semicircular plate is one body and simple block of height 40 millimeter, length 90 millimeters. This rectangular block has a slot of 10 millimeter thick and circular hole. So let's proceed. I'll construct first of all this block, and then I'll attach semicircular plate to the block of radius 35, and then we'll make holes and slot. Remember, holes and slots, such smaller details after completing the major part. So let's proceed. It is a block of 90 length, 35 width and 40 height. So length and height first. So I've clicked here. Length 90, enter, then height 40, enter, and just by tracking the points we will be able to complete it. Now check here, you can draw lines on length, along length and height only, because you have selected length height plane. Now we'll select here length width plane, that is this plane. So here now we'll able to create width. How much is that width? 70. Enter. And now height we have already measured, simply track that point, watch here. And here. Escape. Now let's complete this box. So I'll create top plane. Now we are going to construct top plane. So watch here, isoplane top. I've created line, and from here just trace that point. Simple. It's that simple to construct. Now escape. Now I'll construct semicircular plate. That semicircular surface which appears in the top view. Check in the top view. So in the top plane you are going to construct semicircle, but in isometric view it will appear an isoellipse or semi-isoellipse. So let's construct it. Ellipse. In this ellipse, axis end. When you type axis end, select isocircle here in the command bar. So isocircle. Now specify center of isocircle. So first I am creating that base. So here that triangle represents center, midpoint of that edge. So that is what we have created. So click here, that is the center, and now it is asking us radius. AutoCAD is asking us radius. So radius 35, enter. So this is how we have created that semicircle, but no, it is complete semi-ellipse. So the unnecessary portion will trim. So trim, enter, and check it. Now this is a base of that semicircular plate. Escape. Now I'll move that base upwards, but check here that hair cross. Height axis is not present here, and we are going to measure height for that semicircular plate. So we'll consider the plane that gives you height axis. That is, you can choose ISO left or ISO right also. Correct? I'm choosing ISO left. So I've selected it. Now copy, not move, copy. The same identical surface is at the top. So I moved it upwards. And how much upwards? So type 20 millimeters and enter. So exactly at 20 millimeters you got it. Now escape. Now this curved semicircular surface must have its boundary generator. So line, quadrant point, check it. So click here, and on the lower surface quadrant point, click here. Now line from this point to this point, that is the joint where semicircular surface meets that vertical surface, that joint. Now remember, visible surface, edges over the visible surface are hidden, and we don't show hidden details in isometric view. So those portion of edges on the visible surface you are going to trim. So trim, enter. Now watch here this. And now select it and erase. Also one more thing, this portion to be erased. So trim, enter, and I've erased it. Now why we have erased this portion, this line? That is because this rectangular surface of the block and this semi-cylindrical surface, they meet here tangentially. Check here, there is no sharp corner here. Okay. Yes. Now top surface, here we are going to create that circular hole, opening of the circular hole, top surface. So top surface means we should choose length and width, width plane, that is top isoplane. And here we will locate center first. Check, where is that center? 30 millimeters from left edge of the block, from left edge of the block. This is edge on the left side, parallel to width. So identify that edge from its midpoint at distance 30 millimeter, you will get the center. Okay, so let's do that. Now check here. We want to draw isoellipse here. So axis end, isocircle. So you will have to look at center. So check midpoint here, midpoint of left edge of the block. And don't click here because this is not the center. We are selecting center. So from this end or from this point at distance 30 millimeters, check that axis of symmetry parallel to length axis, 30 millimeters, enter. And now we have selected the center. And what is the radius of this circle? Let's check it. Radius is 20. So 20, type 20, enter. So we have created that. Now the 10 millimeter gap. So draw these two straight lines first. So from axis of symmetry, this axis of symmetry is parallel to length. From axis of symmetry 10 millimeters and 10 millimeters. No. 5 millimeters and 5 millimeters you should measure on both sides of the axis of symmetry. And this 5 plus 5, that is 10 millimeters to be measured parallel to width axis. Okay. So here it is. Line. Here it is midpoint. So 5 millimeters from midpoint. 5. When you type 5, be sure that midpoint, that is that triangle, green triangle is visible and tracking line is visible. Tracking line suggests you that you are measuring that 5 millimeter distance along that line, and that green triangle suggests you that 5 millimeter distance you are measuring from that green triangle, that is from midpoint. So 5, enter. So now I'll draw a line parallel to length. Slight longer line is okay because that can be trimmed. Now trim, enter, and I've erased it. Escape. Now this line parallel to this line at distance 10 millimeter, because we are going to create opening of the slot which is 10 millimeter wide. So select it, copy. You can use offset command also, and now 10 millimeters I'll measure. 10, enter. Okay, so this is how you have created that. Now this is gap or a slot. So there should not be these two edges. We'll trim unnecessary portion of the edges. So enter. Watch it. Now remember, corners are formed by 3 edges. Now here it is corner at the top surface formed by 2 edges parallel to length. Sorry, this is width. Parallel to width and parallel to length. Now from this corner parallel to height there is an edge. Now check which plane you have chosen right now. Iso top. So top means length and width. Height axis is not visible here. So we'll select iso right plane because height is available here. So from this corner there is vertical edge, but through the gap the edge is visible. So only that portion of edge which appears in the gap you are going to show. So trim, enter, So I have trimmed it. Similarly, from this corner also there is vertical edge, but that is hidden because this is top surface, and of course top surface is visible. So edge over the visible surface is hidden. So you are not going to show that edge. Then from this corner also there is vertical edge. So this is opening of the hole. So through the opening some portion of the edge is visible. Draw that. Unnecessary portion you trim it. So check it. I have trimmed it. Similarly, from this corner, try to understand. From this corner there is vertical edge. From this corner there is vertical edge. From this corner there is vertical edge. Similarly, from this corner also there is vertical edge. It's common sense. So no intelligence is required for that to know that. From each of these corners, so from this corner there is vertical edge. From this corner there is vertical edge. Only thing is we are showing those vertical edges which are visible. So similarly, from this corner also there is vertical edge. So click here, from this corner there is vertical edge. So you can draw a little longer edge and then erase or trim the portion, enter, which is unnecessary. So this is how we have completed the drawing, simple. Now we will draw necessary center lines. So line, watch here, from this midpoint, slightly extend the boundary. Okay. Then line here, midpoint. To pan the drawing, you can use mouse wheel. Click here. So this is center line. So I'll select, first check whether center line is there. No. So we'll have to load it. So center line, load. So check. Remember, we don't show hidden details in isometric view. So hidden line is not required for isometric drawing. Here it is, center line. Okay. Okay. So now this line should be center line. Center line. Properties, line type 0.3, enter, escape. So this is how I have created the center line. Now here, match properties. So select it, match properties. Similarly, center line parallel to width axis, length and width in the top surface. On the top surface, this opening is. So let's draw the line. When you move your cursor, after selecting a command, I have selected line command. When you move your cursor on the circle, the Autocad software will indicate center of this circle. Check here. Here it is. So that circle there suggests you that you have selected center, but don't click here. Track that center and slightly outside the circle, click it and through the center. Now check here. It is length and height plane you have created, and that is why parallel to width line you will not able to draw. So select the plane where width axis is available. So width axis is isotop. Okay, and slightly outside the boundary you click it. Now match properties. Now one very important thing. We forgot to select thickness for our construction lines. Here, check here. This is the thickness you have selected for construction lines. That is, actually it was present right now when we started drawing and we forgot to select the thickness. So the AutoCAD has selected default thickness, and now default thickness is actually very thick. Then why we can't see here that thickness, this default thickness here in the line? because that line weight key, toggle key is off right now. If you make it on, the AutoCAD software will show the thickness of the line. So I made it on. So check here. Now all these lines are of the default thickness. We don't want all the lines of for default thickness because center lines are not thick lines. Construction lines are not thick lines. Now right now there are no construction lines, but there is center line. Also these edges, we'll have to choose proper thickness for this. So I'll choose the thickness for edges. I'll select all edges simultaneously, and for these edges I'll select thickness 0.35. That is enough for us. Escape. And center line I'll select thickness 0.15. Thickness 0.15. Enter. So this is how we have completed the drawing.